Hello everyone, welcome to the AI playlist. My name is Mohit Chhabra, ex Salesforce, ex Walmart, and in today's video we will talk about evaluation metrics. So the first question comes in mind, what is evaluation metrics? Basically, evaluation metrics is used to measure how good your machine learning model is, especially for classification problems. Now the most common ones used in this are confusion metrics, accuracy, precision, recall, F1 score, ROC AUC. Don't worry about all of these now. We will talk in detail about each of this in this video. So just to give you the brief, the confusion metrics is kind of foundation for other metrics. The accuracy is overall correctness, like how much your data is correct. Precision and recall focus on the positive predictions. Basically, you will have false positives, true positives, and here the focus will be on the positive predictions. Talking about the F1 score, this is kind of harmonic mean of precision and recall. And then ROC AUC are comprehensive performance measure. So these all are common parts of evaluation metrics, and these are used to measure how good your machine learning model is. So let's talk about each of these in detail. So let's first talk about the confusion metrics. So confusion metrics is a table comparing predicted labels versus true labels. So I will explain you with an example, but before that you need to understand four important terms. First is true positive, second is false positive, then false negative, and then true negative. Here you can see we have actually created a table. In the row you can see actual positive and actual negative, and in the column you can see predicted positive and predicted negative. So basically confusion matrix is a table which compares the predicted labels versus the true labels or the actual labels. So let's first try to understand all these four terms: true positive, false negative, true negative. These terms are actually commonly used, so we should know the actual meaning of these. So let's first talk about true positive, which is also said TP in short form. So for true positive, it means that we correctly predicted the positive. As an example, there was a spam email and we detected as a spam, so it was actually spam, and we also detected it as spam, so we did true positive. The next case is true negative, which means we correctly predicted negative. An email was not a spam, so it was a good email, so not spam, and we also said it's not a spam, so it was true negative. And after this, the third term is false positive. It means we incorrectly predicted positive. So for example, in a spam detection system, an email was there which was actually not a spam email, but we flagged it as spam, so it was a false positive. Why it's a case of false positive? Because we incorrectly predicted, that's why it's false. But why positive? Because it's a spam detection system and we gave a positive, that is it's a spam, but actually in reality it wasn't a spam, so it was a false prediction, hence it's a false positive. And the last case is false negative, that is we incorrectly predicted negative. So example of this in spam detection can be, we missed a spam email. So there was a spam email, so we should have detected that, but we said no, it's not a spam email, so it was false negative. So how to remind all this? See, you can divide it in two terms. So the first one would be our prediction. So if we predicted correct, we will say true, and if we predicted it wrongly, then we write it false. Okay, so the first thing is our prediction, and the second half is actual thing. Say for example, in a spam detection system, positive will mean it's a spam and negative will mean it's not a spam. So you can now understand it very easily. True positive, first half true, it means we predicted it correctly. Second half positive, which means the actual result. So in a spam detection, positive will be that it was a spam, so we correctly predicted it was a spam. Similarly, if you see an example of false positive, first half false, it means we incorrectly predicted, correct? And the second half positive, in a spam detection, positive will be it's a spam, so we incorrectly predicted it as a spam. So basically it was a good email, that is, it was not a spam, but we marked it as spam. And the last example, if we take false negative, first half false, it means we predicted it incorrectly, and second half negative, so it was not a spam. So we were not able to predict a spam email. It was actually spam, but we did not mark it as spam. So based on this funda, like first half is your prediction, second half is actual. You can simply remember these four terms: true positive, true negative, false positive, false negative. If you remember this pattern which I just told you, dividing it in two halves, first is your prediction, second is the actual one, it will be very easy for you to know what each of these stand for. Let's see this with an example. So as we were talking about spam detection in an email, how to classify an email. First, let's see the true positive side. So the first half is true, it means you did correct prediction, and the second half is positive, which is the actual. In a spam, if positive means it was a spam email, so it was actually a spam email and you predicted it correctly, so correctly identified as spam. Now let's see another example of false negative. First thing is your prediction, so you did incorrect prediction, and second half is actual negative. In case of spam detection, negative means it's not a spam. So it was not a spam, but you incorrectly predicted it as a spam. So it was a good email, but you predicted it as spam. Let's see another example. True negative. First half tells your prediction, so you correctly predicted it because it's true. Second half is negative, so which is actual thing. So in case of spam detection, negative would mean it was not spam. So it was not spam and you correctly identified it as not spam. It's a good email. Okay, the fourth case, false positive. First half tells your prediction, so you incorrectly gave the prediction. Second half tells you the actual thing, so positive. In a spam detection, positive means it was a spam, so you incorrectly flagged it as spam. So I hope you got an idea. We discussed it with an example, and basically dividing it in two halves makes things quite easy. So this is basically your confusion matrix, which talks about the predicted results versus the actual results, and these four terms are important to understand in confusion matrix. Now after this, let's talk about the second one, which is accuracy. Accuracy, we know we use that in day-to-day life as well. It means that how many correct prediction did you make among the total predictions. So when we talk about the correct prediction, what would it be? Like we talked about four terms, right? True positive, true negative, false positive, and false negative. So which among these are correct predictions? I told you the first half is always our predictions and second half is the actual one. So wherever the first half is true, that is the correct prediction. So true positive and true negatives are the correct predictions. So what will be accuracy? Accuracy will be true positive plus true negative. That is all the correct thing that we predicted, divided by total, which would be true positive plus true negative plus false positive plus false negative. So once you understand the meaning of all four of these terms, okay, and the logic that we applied, like first half represent our prediction and second half represent the actual result. So based on that, this formula becomes very easy, because you just need to tell like what all correct we made like whichever is true on in the first half. So true positive and true negative are correct predictions, and total will be true positive plus true negative plus false positive plus false negative. That means all the cases, okay, that will give you accuracy. So for example, in a spam detector, say for example there were 100 emails, and out of those you made 90 correct predictions. So 90 includes both like true positives and true negatives, which means that you were able to identify the emails which were spams, and you did correctly identify some of the emails which were not spam. So both combined, true positive and true negative, is 90. And what will be the accuracy? 90 divided by 100, because there were total 100 emails. So your accuracy becomes in this case 90%. So now let's see when this matrix is not good. Say the data is imbalance. Say for example, talking about the spam detector, 95% were good emails and only 5% were spam. So this is a very imbalanced kind of case, right? There is only 5% of spam and 95% are good emails. So in this case, even if the model always says that it is not spam without doing any calculations or prediction, it just says like it's not spam, even then it is getting high accuracy, which is 95%, but it's not a good metrics to judge because this was very much imbalanced. So even if you say 95% accurate results, but it does not make any sense because you did not identify even a single spam email. So it was a very bad model. Still the 95% accuracy shows like it's a good model, but it was actually a very bad model. So accuracy metrics is actually good when the data is balanced. Say for example, you have 50% spam mails and 50% non-spam mails. So in this case, if your model always says like it's not spam, so your accuracy will be only 50%, which you can judge it's not a good model, right? So accuracy is a good metrics when your data is balanced, but it is a bad metrics when your data is imbalanced, because then as we saw, the wrong model can also appear as a accurate model, which is not correct. So after accuracy, let's talk about precision. So precision focuses on true positives. Like among all the positives that you predicted, how many of them were true positives? Like for example, if we are talking about the spam detector system, so positive in a spam detector would be to detect a spam email. So how many spam emails you detected? So basically the precision will be true positive divided by true positive plus false positive. So how many true positives out of total positives predicted? So your positives predicted will be true positive plus false positive. So your precision will be true positive divided by true positive plus false positive. So let's understand this with an example. Say for example, we are talking about spam detection model. So true positive in it will be when you detect a spam email, and false positive will be it wasn't a spam email and you predicted it correctly. So let's say our model flagged 20 emails as spam, but out of those only 15 were actual spam. So just looking at these two statements, our model said like 20 spams, but actually there were only 15 spams. So it means that our system 15 true positive. Why? Because true positive means true, that we did a correct prediction, and positive here would mean a spam. So we correctly predicted a spam. So 15 is a TP because there were 15 actual spams, right? And out of 20, remaining 5 will be false positive. Why false positive? Because false here means we incorrectly predicted a spam. So we predicted spam, but it was not spam, so it was false positive. So what will be precision? Precision will be TP, that is 15, divided by TP, which is 15, plus FP. False positive were here 5 because we incorrectly predicted it wasn't spam, but we predicted as spam, so it is false positive. So 5 here. So 15 divided by 20, which means 75%. Okay, so our precision will be 75%. So clearly when there is high precision, it means we have few false positives because it's true positives divided by true positive plus false positive. So higher the precision, lower the false positives. So basically when we talk about precisions, our main focus is at the true positives. So in example of spam detection, how many emails correctly predicted as spam which were actually spam divided by total number of emails that we predicted as spam, because that would be TP divided by TP plus FP. Now after precision, let's talk about recall, which is sensitivity or true positive rate. If you check the formula, it is slightly different from precision. In precision, we had like true positive divided by true positive plus false positive. Whereas in recall, we have true positive, which is same as a numerator, but the denominator is different. It's like true positive plus false negative. In precision, it was true positive plus false positive. Here we have true positive plus false negative. So in spam detection, true positive will mean you correctly predicted spam email, and false negative will mean that you incorrectly predicted non-spam email. So in normal terms, if we say of all the actual positive instances, how many did the model correctly identify? So let's say there were 30 spam emails, out of which model only detected 15. So 15 would be true positive because you correctly identified spam emails. Now for remaining 15 spam emails, you said those were not spam. So remaining were false negative because you incorrectly predicted that it was not spam, but actually it was spam. So false negative is also 15, which is 30 minus 15. So what will be your recall rate? It will be 15 as your true positive, which is again 15, plus false negative, which is 15 here. So 15 by 30, so it's only 50%. Here 15 and 15 both came same as a true positive and false negative. If we slightly modify it, say the model detected 16 mails as spam. So in that case, 16 will become your true positive and your false negative will become 14. 30 minus 16, 14. So remaining 14 were false negative because you incorrectly predicted that as non-spam. So in that case, your recall would be 16 divided by 30. Okay. So basically high recall will mean few false negative because it's like TP divided by TP plus Fn. So denominator is Fn, hence if your recall rate is high, it means the false negatives are low, and that means that model catches most of the spams, because in spam detection model, detecting spam would be a true positive. Higher the true positive, higher the recall. So in terms of formula, very slight difference between recall and the precision. Precision is true positive divided by true positive plus false positive. Recall is true positive divided by true positive plus false negative. So after recall, let's talk about the fifth one, which is F1 score. So as you could see that precision and recall had very similar kind of formulas. Now to make things more interesting, F1 score is harmonic mean of precision and recall, which means it balances both of these. So if you see the formula, F1 is 2 into precision into recall divided by precision plus recall. So it's a harmonic mean of these two things. So creating a balance using precision and recall is your F1 score. So precision basically measures the accuracy of positive predictions, and recall measures the ability to capture all positive instances. So you take the balance of both of these and create a F1 score using the harmonic mean. When do we use it? We use it when we want a single metric combining precision and recall, right? You have two matrices. If you want a single metric which combines both of these, then F1 score is a good matrix, and it is very much useful when the data is imbalanced. Last but not the least, let's talk about ROC and AUC. ROC stands for Receiver Operating Characteristics Curve. It is basically a graph which shows the trade-off between true positive rate, that is the recall, and the false positive rate, which is false positive divided by false positive plus true negative. And AUC stands for Area Under Curve. It's a single number which summarizes the ROC curve. Closer to 1 means the better model, and 0.5 represents the random guessing. So ROC AUC help comparing the models by seeing how well they separate classes at different thresholds. So in this video we checked 6 different things in terms of evaluation metrics. Now let's check the summary. So first we talk about the confusion matrix, which creates a table between the predicted results versus the actual results, where we understood 4 terms: true positive, true negative, false positive, and false negative. So all these 4 terms we understood in the confusion matrix. So understanding these 4 terms was very important because we will use all 4 of these for different metrics. First is accuracy, which measures the overall correct predictions. It is good when there is balanced data, and it can be misleading on imbalanced data, because we saw, say for example, there were 95% emails which were already good and only 5% were spam, and if your model does not do anything and just says that it's a good email, then the accuracy would be 95%. So in case of imbalanced data, accuracy is not a good metric. The second metric could be precision. It basically measures correct positive predictions. The next one is recall. It basically measures the coverage of actual positives. We also saw the formula between precision and recall is slightly different based on the denominator. So the formula for precision was true positive divided by true positive plus false positive. Okay, whereas for recall the formula was true positive, that is the numerator is same, then you have true positive plus false negative. Okay, you might get confused in these and you might say how to remember this. I have a trick for this. So precision starts with P, and if you see the formula for this, everything as P, TP, TP, FP. Okay, so P for precision and it contains all the P's. So true positive divided by true positive plus false positive is precision. So recall is slightly different, like it will be same numerator. You have just FP replaced by FN. Okay, so easy to remember because there is P for precision, and then you just need to change FP by FN because you don't also have any other option. So it's an easy way to remember this formula. And then we have F1 score metric, which is balance of precision and recall. So it provides the harmonic mean of precision and recall to provide a balance. So basically in a single metric we are able to see the balance of precision and recall. And then lastly we have ROC AUC, which measures separating classes across thresholds. It is good in comparing the classifiers, and what we need to watch out is it requires probabilities. Alright, that was a good summary. We covered a lot of things in this video. We discussed about the evaluation metrics and various things that are used in it. I hope you got the basic concepts through this video. In case you have any doubts, put that in the comment section. I'll try to help you out. If you found this video helpful, press the like button and share it with your friends so that all of us can become AI Pro. Alright then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.